So today I will discuss the definition of round robin. So what is round robin? Round robin scheduling, or RRS, is a job algorithm that is considered to be very fair, as it uses time slices that are assigned into each process in a queue or line. Each process is allowed to use the CPU for a given amount of time. So these are the advantages of round robin. There is fairness since every process gets equal shares of CPU. So all the processes are given the same priority. Number 2 is the newly created process is added to end of ready queue. And number 3 is that round robin scheduler is generally employed time sharing, giving each job a time slot or quantum. Number 4, while performing the round robin scheduling, a particular time quantum is allowed to different jobs. And number 5, each process get a chance to reschedule after a particular quantum time in this scheduling.
Round-robin disadvantages. Setting the time quantum for too short increases the overhead and lowers the CPU efficiency, but setting it too long may also cause poor response to short processes. So we suggest that you should set the time quantum just exactly, not too short but not too long also. Also, one of the disadvantages is that there is larger time waiting and response time for that also comes with the gunshot. That will seems too big if your time quantum is lost for scheduling. One of the example is for example 1 ms for big scheduling. Also, one of the disadvantages is that if you set a small quantum, it is time consuming. That's all for the disadvantages of round robin. Let me just explain also the times that we consume on round robin processes. Arrival time. It is time when a process enters into the ready state. That just means that the process is ready for their execution. Turnaround time. This is the amount of time that the process exists or run into the system. Waiting time. This is the amount of time that the process taken by the completion of their execution, or to make it simple, the time spent by a process in the ready state waiting for the CPU. Burst time, or also known as execution time. This is the total time taken by the process for their execution on the CPU.
Consider the following sets of processes that arrive at time 0 with the length of CPU burst given in milliseconds and time quantum taken as 4 milliseconds for the round robin scheduling. Here we are given a set of processes with the process ID of P1, P2, and P3, and their burst time is 24 milliseconds. P2 has 3 milliseconds and P3 has also 3 milliseconds. And we assume that all arrive at time 0. We have a particular process time quantum which is 4 milliseconds, and once the time expires, the next process executes, and so on. First, we have to do the Gantt chart, which is P1 starts at 0 to 4 milliseconds because the maximum the quantum time taken is only 4 milliseconds. Then at the next is the from 4 milliseconds to 7 milliseconds is P2 because the P2 is only 3 milliseconds, and with the because P2 is only 3 milliseconds and less than the time quantum that is 4 milliseconds, it will voluntarily preempted, and the next in the queue will execute, which is the P3 with 3 milliseconds. Um, the same as the P2, P3 also has 3 milliseconds, which starts from 7 milliseconds to 10 milliseconds. After that, we see that there are no more in queue, but in reality, the P1 will execute because it has 20 milliseconds remaining in its burst time. From 10 milliseconds to 40 milliseconds, P1 will execute, and then P1 will be preempted, and then P1 will still execute because it has 16 more milliseconds, excuse me. It has 16 milliseconds of burst time remaining. Then P1 will start again with 14 milliseconds to 18 milliseconds, and then it will be preempted and will execute again to 18 to 22 milliseconds, and then P1 will be preempted and P1 will still continue because it has 8 more milliseconds remaining of its burst time. Then from 22 milliseconds to 26 milliseconds, P1 will be preempted, and then last from 26 to 30 milliseconds, P1 will finish its execution.
Process 1 is 30 completion time, and process 2 is 7 completion time, and next is the process 3 is 10 completion time. The method of turnaround time. The formula is completion time minus arrival time is equals to turnaround time. Process 1, 30 minus 0 is equals to 30 milliseconds turnaround time. Process 2, 7 minus 0 is equals to 7 milliseconds turnaround time. Process 3 is 10 minus 0 equals to 10 milliseconds turnaround time. Next is waiting time. The formula of this is turnaround time minus burst time is equals to waiting time. Process 1, 30 minus 24 is equals to 6 milliseconds waiting time. Process 2, 7 minus 3 is equals to 4 milliseconds waiting time. And the last is process 3 and 7 milliseconds waiting time. Average turnaround time, 30 plus 7 plus 10 divided by 3. So it will become 47 divided 3 equals to 15.66 milliseconds. Next is getting the average waiting time. 6 plus 4 plus 7 divided by 3. So it will become 17 divided by 3 equals to 5.66 milliseconds.
This is the round-robin scheduling program we created. We utilize Java as a programming language and Java Swing Form to implement the program's visual design. Now, we will try to run the round-robin scheduling program. First, click the Start button to begin the program. Next is enter your desired number of processes. I entered 5 for the number of processes. In this part, the user must enter the burst time for each process. There is 5 processes, so it will ask you to enter the burst time from process 1 to process 5. In process 1, I'll enter a value of 2 milliseconds. In process 2, I'll enter a value of 3 milliseconds. In process 3, I'll enter a value of 5 milliseconds. In process 4, I'll enter a value of 8 milliseconds. In process 5, I'll enter a value of 10 milliseconds. In this part of the program, a user must enter a value for the quantum time. I'll declare a value of 3 milliseconds for the quantum time. This is the result of the process of the round-robin scheduling. We can see the burst time, turnaround time, and waiting time for each process in this section. We can also see the average waiting time and the average turnaround time. To go back to the main menu, click the Close button. Click the Quit button to close the application.
Here, I have a table where I have shown the process with the process IDs of process 1, process 2, process 3, process 4, and process 5. Here, we have the completion time of each process. To see the completion time, we can just look at the Gantt chart and find it out. If you see, for process 1, when did it completely finish its execution? So we see that process 1 completely finishes execution at 2nd millisecond. So that's it, the last occurrence of process 1 in the Gantt chart. So second will be the completion time of process 1. Now for process 2, the time complete was 5 milliseconds. So 5 will be the completion time of process 2. For process 3, 16 milliseconds is the completion time. For process 4, 24 is the completion time, and for process 5, the completion time for process 5 was occurred in 28 milliseconds. Therefore, 28 is the completion time of process 5. Now let's calculate the turnaround time. The formula for turnaround time is turnaround time equals completion time minus arrival time. The arrival time of each process was 0 because they arrived at 0 millisecond. So the turnaround time of process 1 will be 2. 2 is the completion time minus 0 equals 2. So the turnaround time of process 1 is 2. For process 2, 5 minus 0 equals 5. Then 5 will be the turnaround time of process 2. For process 3, 16 will be the turnaround time because 16 minus 0 equals 16. For process 4, the turnaround time is 24 minus 0 equals 24. And for the process 5, 28 minus 0 equals 28. So 28 will be the turnaround time of process 5. And now let's calculate the waiting time. So the formula for waiting time is waiting time equals turnaround time minus burst time. So the waiting time of process 1 will be turnaround time 2 minus the burst time which is 2. So the waiting time for process 1 is 0. For process 2, 5 minus 3 equals 2. So 2 milliseconds is the waiting time for process 2. For process 3, 16 minus 5 equals 11. 11 will be the waiting time for process 3. For process 4, 24 is turnaround time minus the burst time which is 8 equals 16. 16 will be the waiting time for process 4. And for process 5, 28 minus 10 equals 18. 18 will be the waiting time for process 5. Now, for calculation for the average turnaround time, we add the turnaround time of each process, then divided it to the numbers of process, which is 5. The turnaround time of process 1 is 2. For process 2 is 5. Then for process 3 is 16. For process 4 is 24. And for the process 5 is 28. So 2 plus 5 plus 16 plus 24 plus 28 equals 75. 75 divided by 5 equals 15. So the average turnaround time is 15 milliseconds. Now, let's calculate for the average waiting time. The formula for the average waiting time is same in calculating of average turnaround time. The waiting time of process 1 is 0, and for process 2 is 3. For process 3 is 11, for process 4 is 16, and for the process 5 is 18. So 0 plus 3 plus 11 plus 16 plus 18 equals 47. 47 divided by 5 equals 9.4. So 9.4 milliseconds will be the average waiting time.
Now, let's compare the result of the round-robin scheduling case in the application and the result of what we processed and computed manually. The results are exactly the same. This demonstrates that our program is operating correctly.